a little bit more info about those stickers. This topic that these two lovely guys will be talking to us about today is actually one of the Eclipse SDV projects. And some of the challenges in this year's hackathon will actually involve knowing a bit about this project. So you'll probably see more of those stickers at the hackathon as well if you'll have the benevolence to join us. But definitely make sure to get a couple of them.
No. Okay, let me try
to the right, a bit more to the right. All right. Who has been here this morning already for Steve and Kai? Okay, so maybe you do have to reintroduce yourself at least a little bit.
Why can't I get
But
this
we'll be there in a second. All right. Welcome, everyone. We are in the middle of the afternoon slump. So again, anybody who wants to get up and get a sticker, please do that. We won't mind. No, one back, right. So this is the follow-on, if you want, to the presentation that Kai and Steven given this morning. And this time we are going to be speaking about the uProtocol project, the Eclipse uProtocol project. We will speak about why that has come about. You know, why is this a thing? What are we doing here? And how are we trying to do it? With me is Steven, who is essentially better qualified than me in every aspect because he invented all of this. Maybe, Steven, if you want to say who you are for the three people who haven't been here this morning.
So my name is Stephen Hartley. I'm an alcoholic, so no, just kidding. Former GM, project lead for uProtocol. I think now an evangelist for this whole initiative because I really enjoyed working in it. And in a couple weeks, I'll be working for BlackBerry, so QNX, so we'll see how that goes. So, yeah.
Yes, my name is Daniel. I've been around this community essentially since the beginning. I was one of the reasons or instigators, let's say. I have been in the industry for, I don't even know, 18, 19 years. Spent a lot of time in diagnostics, telediagnostics. And essentially for 3 years now, my main focus and the majority of my time is being spent doing open source work. Last year of that in this project. That's how we met.
Oh. It was love at first sight.
Right.
It's okay to have bromances in software, too.
Yes, especially in open source, right? This is what this is all about. Okay, so why are we here? What is the rationale or the thought process that gets you to come up with something like uProtocol? All of this started because essentially we do have computers in cars. I think that's something that we have heard about hundreds of times over the last couple of months, years. Specifically, or semi-specifically, but you know the kinds of computers we have. You know, it ranges from the low-level mechatronics controllers up to high-performance compute with normal, decent operating systems and software stacks and libraries and transport protocols and whatever, what have you. And the point is, we have those computers. I mean, we are geeks. We like computers, but also we want the computers to run things, right? That's the reason to have them. And essentially, that's what we do. All of these computers run a bunch of applications, hundreds, dozens, depends on the system, depends on the sizing. But at the end of the day, that's why we do these things. And generalizing one more bit, where in this entire picture, lots of boxes, and we do love, especially we love the lower level boxes, right? Again, we are nerds. But why are we doing all of this? Where's the actual value in the product? That's that small app layer on top. And this is where the business logic is, right? This is what you have to, the product builders, the OEMs, what they have to bring to market and maintain in a kind of coherent way for ideally 10, 15 years, across the model lines, across time, etc. That's why we're doing this. Everything underneath is necessary. And again, I don't have to tell you guys that, but at the end of the day, that is plumbing. And we operate as humans, and especially as automotive humans. Every one of these tech stacks, every one of these boxes bring their own programming model, right? So at the end of the day, what I said, the important bits are the applications and the services on top. We do deploy them to a range of very different systems. Every system brings its own programming model, its own transport protocol of the day, its own tool chain, its own mindset, its own engineering culture, if you're lucky, because these things usually spread around organizations, right? So every box here probably represents a department. And the question that we can ask here is, do we really want to be spending all of our efforts continually working with, changing, reinventing, maintaining, figuring out the next hot plumbing of the day? Because the plumbing is, it's light. Without plumbing, there's nothing. On the other side, plumbing is invisible. Nobody sees the plumbing. That's not what I hate the word, but what the differentiating piece is. It's perfectly boring to anyone other than nerds. We have to have it, and if we have too much of it, back to the previous picture, it makes things complicated for everyone, right? Because nothing fits. Everybody has to map their own concepts and mindsets to the next guy's plumbing, etc. So plumbing happens to be, because of all of these properties, the ideal playground for an open source community, right? We are all nerds. We love working on plumbing. Now we can do it together. And ideally, if we manage to do this together, at least to a certain extent and degree, plumbing can become the crystallization point for, again, a bad word these days, but the starting point for a little ecosystem, right? If things agree to use the same programming model and plumbing, and you kind of work with that out of the box, you can actually plug things together, at least better than you could before. So that's the why. Why is this kind of project, in our mind, a very nice fit for an open development model? And the what, quickly. So what is this about? We talked about, I mentioned apps and services, and we talked about the important properties that we want there, right? We want to be able, from each application, to reach each service in our domain, or like in our world, really. It doesn't matter where to where. But we want to be able to have that communication being simple and ubiquitous, because we don't want to care on that business about the day, right? And the tech stack that somebody chose down there because they had a nice golf game the previous weekend, etc. So that is one of the goals, that we would like to make those apps, the people doing the apps, to enable them to become a bit more efficient about what they're doing, especially looking at the time aspect. Again, we need to maintain this stuff, ideally, right? You don't want to rewrite your business layer every other year. So if you decouple a little bit, at least, that logic, that value from the plumbing, that might change next year, again, because things happen, that will help us. And at the end of the day, what I mentioned, and it's kind of implicit, and we mentioned Conway this morning, every one of these boxes, every one of these colors represents a different organizational unit, department. It's very hard to get people to talk, and if they talk, it's very hard to get them to speak the same language. So the right kind of plumbing with the right kind of concepts can help make that a lot easier, because you begin to align on your view of the world, of the vehicle, whatever. So this is essentially the takeaway from that first section. We have a bunch of plumbing, and we will get new plumbing every other week, because again, we are all geeks, we like plumbing. But that does not help with the high-level business goals for the business logic layer, for the business value. So what we want, we think, or actually these guys not only thought, but essentially proved, we want an open source automotive service mesh that transforms the kind of zoo that we saw, the application zoo, into something that's a bit more coherent, manageable, maintainable, etc.
One point I want to mention too is that in a software-defined vehicle these days, software, like I think I mentioned this morning also, it doesn't just run in one of those boxes, in one of those events. You always have something that has a cloud component, a vehicle component, a mechatronics component. And if you want to assemble them together, you have to talk across the 5 different business units, 3 suppliers, define signals and wait 4 years, and so on. The idea with a service mesh is making all of the functionality and capability that these services could provide, like brake controls or lighting controls or HVAC controls, exposed such that you can create these distributed applications or distributed services. Are you going to talk about
Actually,
the
this
name?
is the perfect handover point. What name?
The mesh
logo.
versus mesh.
Yeah, everybody who got a sticker can read our motto, turning the service NES into the service mesh. Essentially, that is the mission statement for uProtocol, if you want. I listed a couple of, let's say, desirable properties for the kind of middleware that we're talking about here. And this has been the preparatory section for how this is supposed to work. This is where I hand over to Stephen.
All right, so I'm going to just give you a couple of basic concepts and principles that we have in uProtocol. And some like to call it, we like to call it a communication abstraction layer. And this morning during the Zeno talk, there was some diagrams that were shown. Actually, that's our roadmap slide that shows how we're integrating all these technologies together. And why do we have to have this abstraction layer or service mesh concept? Is because I cannot convince cloud people to adopt some IP, right? Good luck. I can't convince the embedded mechatronics AutoSAR classic environment to use, let's say, Zeno, or maybe I will one day, or these other technologies that exist in the cloud. So if I want to have some way of having an app talk to a service to do very basic things that was presented during that Fanny presented this morning about publish, subscribe, and queries, I want to be able to just say publish. And if I'm publishing over a different technology, I still just want to publish. And so what we try to do is we try and create some sort of a common high-level basic definition of, good old anyone who's written first of all, has anyone written a protocol in their career? Like, okay, a few of you. What is the basic thing that you always have in a protocol? A protocol has 2 parts to it in a protocol data unit. You have a header and a footer, or a header and a payload, right? So what we're trying to do is we're trying to standardize that header that can then be translated and put across all of these different protocols. So in order for us to do that, we need to have some unified addressing scheme. Because some IP uses one method, Zeno uses another, MQT another, DDS, and so on. So we want to have some sort of a unified, simple addressing scheme. But also, Daniel was talking about how it's plumbing, and it's one of those things that I hope in 5 years everyone in the auto industry, or maybe 10 years, will just take advantage of and forget that it exists. Because it's not revolutionary. We're not creating necessarily value for our customers. We're creating a means to enable you to create value for your customers, because this is something that's not revolutionary. It's just simplified. We reuse a lot of internet standards for addressing using URIs and other RFCs for different ways of packaging messages. We support some concepts that I'll show in the next slide about the subscription and so on. But what's interesting is we understand that the automotive industry, we're trying to, okay, let's take a step back. We're trying to create a ecosystem to allow developers to be able to easily build apps and services. And so if you get tripped up and, well, something exists for this protocol or this language, whatever, then you start tripping over yourself. So uProtocol tries to support, right now I'll show we have 5 different programming languages, we have multiple communication protocols, and we keep adding them as we go. As more people come on and say, well, I'd like to do Rust with DDS. Like, great, write the 300 lines of code and now you have that library, right? Or whatever it is. So so unified addressing scheme that we have across all of these, we split things into standard URIs. If you look at an address, each message that is sent across this service mesh has a source and a destination, it has an identification, ID, and so on. And, nice. And the idea is that every single entity in the system is able to be addressed. And then if I want to be able to communicate and enable all of these apps and services, we provide very simple, easy, thin client libraries that people include. So if you're a Rust developer, you pull in the UP-Rust library. If you're a C++ developer, you pull in UP-CPP, and so on. The idea is this library will give you a way to say publish, subscribe, invoke method, and send notification, and so on. And then these APIs will hook into a transport that will actually do that implementation. And it's very interesting about this library and what benefits it served General Motors when I was there, is that we were undecided on which protocols we wanted to use. This allowed us to build a communication mesh between all of these different software components without having to settle on what the transport is at that given moment. We could switch and swap and change and so on. And we have these components that are like infrastructure components. Yeah, streamer is probably not the best name for it. Maybe we should have called it a bridge, protocol bridge. But in essence, what these things do is they're like you know, the Zeno routers that they have. In our case, what we do is we want to bridge from one protocol to another. So if I have this entity is talking some IP to the mechatronics, and then I have another entity connected over Zeno, the streamers will bridge the messages. So really what it does is it's a packet forwarder. So it gets something over one network, creates, takes it off the transport, and then binds it to another transport using the specifications. So uProtocol is not just a bunch of code and libraries. We have a very extensive specification that dictates if you're doing this in Rust or you're doing it in another language, this is what you're supposed to do. If you're writing something for some IP, this is what you're supposed to do. Why? Because we understand that we're going to have maybe a Python implementation of some IP. We might have a C++ implementation. We need it to all be interoperable. So if you're stuffing packets and reading packets over the wire, you need to be able to understand the packet format and so on. And then another point that's interesting is about the cross-domain subscriptions. The idea is that if I am subscribing to a topic, I being an application, no matter where I am in the system, I just say subscribe to topic, right? Revolutionary. But the idea is that I'm subscribing to a topic. I don't care where the location of that service is. As a client, I just call subscribe. What that does is it creates this contract with your local subscription manager, which is another service. And then that entity is responsible, according to the protocol, to reach out to other subscription managers and create that contract and notify the client that the subscription is complete. So in essence, it takes care of subscription management regardless of the transport, because Zeno has one subscribe APIs and subscription management method, MQTT another, DDS another, SumIP another, and so on. So we just provide a common simplified subscribe API, and it works across the board. We don't necessarily talk too much about services, but what's interesting is that the services really is a way of defining a service level API. So the protocol itself is layered into 3 different layers. So that's why I like this diagram here. The layer 1 is really all about how do I take these messages and write them on the wire, we call it. So a wire could be binder, MQTT, Zeno, and so on. If you look at the specification project, you can see they're split up into the basics, which talk about the building blocks, the layer 1 requirements, layer 2, and layer 3. We're also making a huge effort, thanks to Kai, and others, I should say, to include open fast trace into the actual specs, and then the traceability into the individual libraries to verify that the requirements are met, and so on. And then the layer 2 is all about the routing and the different protocols of the publisher-subscriber pattern, the RPC patterns. So if I invoke a method, I need to make sure that I have all of the parameters in there that for timing and acknowledgement and so on. And then the layer 3, when I was getting to the uSubscription stuff, that's the business logic. So the protocol defines the business logic for the 3 fundamental functions that you need to enable the protocol, which is subscription management, service discovery, and twin, which really means I'm caching events that happen in the system. And that we can talk about in a whole other session. But it also provides the building blocks for you to create other use services. And so if anyone has looked at Covisa, General Motors open sourced a whole bunch of their use services, like the climate control, the horn service, the lighting service, and all these other ones, to give examples. And that provides service definitions for messages and commands and controls that you could pass over the protocol. So at the end of the day, the protocol is really about standardizing the header and sending any kind of payload. And some of the payload information that you could pass could be serialized protobuf messages, it could be a string text, it could be anything. And also, that's one thing I just wanted to state with this diagram too. A lot of people keep saying or thinking that we're focused only in the vehicle. If you look, there is actually a UP-ACA project that was provided by Lightband. And so there's quite a lot of cloud-based work. At General Motors, we did a mobile phone version of it, but it didn't end up making it to the open source. But there is, the intention is for it to run everywhere. One other thing that could be related to is it fits nicely with other open source projects. If you look at various other projects that have existed, they actually have a communication component, but they've fixed onto a protocol. And what we're working with the other community members is to say, pull out that specific protocol, use the uProtocol APIs, and then your project can now support any other protocol. So you can easily adopt Zeno or SumIP or MQTT rather than being fixed to, like Cannot, for example, or some various other projects.
At this point, quick shout out to Sven, who has been creating the starting point for this blueprint that we're linking here, which essentially is what you just mentioned. We do have a vertical implementation, showcase implementation for using the Horn use service going through the stack, using the Cuxa VSS data service to, actuate, quote unquote, a hypothetical Horn actuator. And that is essentially a starting point that we plan to spend time on in the coming quarters to kind of complement the service mesh uProtocol story that we just showed you, pull that actually onto real, let's say 2 or 3 different computers, QEMU instances, whatever we'll see, and then pull in, for example, BlueG, potentially any other orchestration layer that we have, we'll see, to affect execution management and probably deployment in that service mesh cluster. But essentially the important bit is, this is the link, this is where that blueprint has started and will continue for, I don't know, we'll have an update next year, I guess.
No,
so
no pressure, Sven.
Anyone who's interested, join us.
So I wanted to highlight a few things. So GM was the original contributor of this project. From the early stage, it was intended to be a collaborative, open source, open collaboration. So before I was complaining about some open source projects where it's open source but not open collaboration. Anyone who's tried to make a commit to Android might know what I'm talking about. But the point being here is that we actually have a large portion of the contribution and now committers who are non-GMers. And so as a result of that, the project has grown considerably. We have large amount of contributions from various individuals from multiple companies, and they keep growing. There's a few other call-outs I'd like to make for Valtech Mobility. They're also a big contributor in here. They don't show up as an actual company name yet, but they're also a very big contributor to this. And we encourage a lot of contributions from anyone. We have a strict guidelines that we follow from Eclipse about being promoted to a committer. And so that was a big culture shock for GMers who thought they can just all become committers, but we're like, no, that's not how the process works. So, you know, we can talk about that offline afterwards, but we encourage contributions from many. So what happens is we have, if you look at the project, there's 40-something different repositories in the project, which sounds daunting, but it's because we have 5 different programming languages that we're all supporting. 1, 2, 3, 4. So there's 4 shown because we also have Kotlin, but we're debating if we keep Kotlin since Java works. And also we're looking for a maintainer. So, but when you have the language and you have the transports, you know, all the different combinations end up to having very many projects. We also built in there simulators. We were working on extensive test compatibility kits as well. When we originally contributed this, we were thinking of making it a specification project, but the community said to us that it made more sense for it to be a project and then build the specification and build the test compatibility suite around the project. That way it's less formality and it's quicker. And honestly, if you look at the commit flow since we went and actively did everything in the open source, it was like a hockey puck, hockey stick, I should say, until a certain point. And last but not least, we are assembling all of these different components to put together for our initial release. And so we're targeting that release sometime near the end of November. You know, like everything that we said this morning and in general, we need to get to that level 3 that I was talking about for those who attended this morning, meaning that we need to understand that, you know, rather than working on another project, why not work with us on this? I want to give a shout out also for Zetascale. They're doing a lot of the Zeno work for us and with us. So they're helping us with the Zeno transport implementations, which make a world of a benefit for us as well. We have support from Bosch, ETAS. Microsoft was doing some contributions as well. So if you're interested, feel free to reach out to Kai, Daniel, myself on Slack, on channel, or
on GitHub.
And that's it. Any closing thoughts?
No, you said it all. Join us if you're interested. Again, this is not an easy ask, but what I said earlier, if we wanted to, this could be, you know, starting point, glue, home for a little ecosystem, at least for our portfolio in the working group. But it takes everybody, you know, to take a look, maybe write an adapter, use this, or at least shout at us because you don't like it. But anyways, this is where you can do that. So everybody's welcome. The call is every week, Thursday.
We actually have quite a lot of time for questions, which is good because we didn't want to go too much into the technical details because that we will really make you guys fall asleep. But I think the best way to get started is to pull one of the libraries included in your project and start playing with it. And you know, let us know if things don't work, create an issue. Don't be shy to push a fix or a change. We are more, even if some people started this whole initiative because what happens is it's hard to get to that point where your company allows you to make a contribution. So your first test contribution could be a spelling correction in the specification. Just that would be greatly appreciated as well because there was a lot of those.
It means someone read the specifications.
Exactly. So thank you very much.
Questions? Come on, don't be shy.
Thank you for your interesting presentation. Well, I didn't know uProtocol before very well, but I know ROS2. So there seem to be some similarities.
Yes.
And, so can you summarize what the differences are, or is that?
So ROS2 is more of a complete ecosystem intended for the robotics. One could say that why don't we just take the entire ROS stack and have it running in automotive? We were more targeted for an automotive and automotive protocols, and also we're not targeting to have a communication middleware that would use one protocol. So the idea of this is to have a mesh, and a mesh of these things that are connected everywhere versus it using a protocol.
Okay, thank you.
So, do you deal anyhow with timing aspects, timing guarantees, or this should be solved on a lower level on the concrete protocols?
Okay, I love that question because I was kind of hoping somebody would ask a safety question as well. Like, is this safe? So here's the reality of the ecosystem. So it's a thin abstraction layer, which everybody says, oh, that's a four-letter word, but it's not when it serves a very important purpose. It's a very, very thin abstraction layer. It takes almost little to no overhead. It runs on top of a communication protocol. So you, as an architect or a software engineer building a product, need to choose the communication middleware that meets your needs. If you need real-time, guaranteed delivery of a message across the network, then you will choose a communication middleware that does shared memory, zero copy, or something. If you want to have something that connects to the cloud, then you have to understand that I can't do guaranteed delivery and so on and so forth to the cloud, so I'm going to use a protocol that meets it. That's one aspect. The second aspect is when there's information that I need to carry across these networks, like for example, I want to generate a message, and that message needs to have some sort of a signature or verification that I can use at the end, or I need to append a token. The protocol allows you to have additional header attributes, and so we've defined it in a way that we can extend it, but we list mandatory headers and optional, just like Zeno does. And so whenever there are mandatory ones, every message absolutely has to have it, and optional ones, they appear in your code when it reads the message and gets it, and some of them include that. Now, the protocol is meant to provide 3 architectural patterns for software developers. It's your responsibility as a business logic developer building apps and services to choose the right one. If you need to send something to someone else, and you need to know that someone else received it, you're not going to use a publish pattern, right? Fundamentally, publish is fire and forget. Now, some protocols provide an ACK in the publish, and that is only at a point-to-point. But if you really need, at a business logic application layer to your service, you need to use a pattern like RPC in order to invoke a command, do something, and get an acknowledgement back all the way to the top. So that was the conversation that I would have often with service developers to say, as you're building your business logic, design in there with the mindset of the way the patterns are expected. Notification is one-to-one, publish is one-to-many, and RPC is one-to-one with acknowledgement. So that was a long-winded answer to your question. Timing, I think.
Any further questions?
Is your protocol already used for some streaming type of data, like camera, radar, or audio? Has it been used? I think it's a similar question in this area, because it depends on the methods, how you agree on data exchange. But just the question, has someone already tried this?
Okay. Thank you for asking that question, because I get confusion from folks previously at General Motors about you're trying to make it a protocol for all. It's not. It's meant for a communication network for a service mesh. It is not a video streaming protocol. Now, that doesn't say that someone can think of, like, why don't I use it for video streaming and I'm going to send the video over some IP? Maybe you could do a project like that, but that wasn't our target. Our target was for application and communication, app to service communication. And even telemetry was not envisioned to be on it. Like, if you need to measure the metrics of the performance of your app and service and how they talk to each other, you're not going to use the protocol of how they talk to each other to do that. You'll use some out-of-bound tool or process, was the thought. But again, it's based on what you want to use it for. But the main target, the main goal is for the service mesh communication, not mess.
That is one of the reasons why, like, if time grants us that luxury, we should probably rename the UStreamer at some point because it's confusing. So
Yeah. That's one of our to-do list items. Thank you.
Anybody else?
Okay, so I was wondering how discovery of the subscription microservices works, because I know we have different transports available. Each transport has its own way of finding each other. So what is the solution there?
You want to get that?
Because potentially we could have also not only vehicle cloud, but we could also have vehicle and vehicle.
Yeah.
I mean, a service on a vehicle talking to another service on another vehicle.
You can explain the details, but essentially there is a level 3 application level, or like plumbing business logic level component for a uDiscovery service, which essentially provides that functionality. The idea is that this is deployed throughout your mesh in a hierarchical manner. So, you might have local discovery service for a network segment, vehicle-wide master discovery, something in the backend, etc. Implementing that thing, in that case, in our Rust code base is on my midterm to-do list, so I haven't really touched it yet. So any more details we have to ask Stephen.
Okay, so there's two aspects of the question about discovery, and then there's about the subscription manager. Both of them have, according to the specification, I'll use air quotes because I wrote their specification and these guys are helping me fix it. So we have specifications on the business logic of how that's supposed to work. So any app can discover any service out there, and it's meant to be able to find what the service can publish, what the service is capable of doing. Is the service present? What is the version of the service? That is one aspect of the question of being able to find services. Now, for subscription, it's a very strong contract. And every system, if you want to have uProtocol, has to have a subscription manager, which is a uService that's running in the background. Now, depending on the deployment, if you look at our Android implementation, the uSubscription service runs in the same entity as another core component, the streamer, the bus, that's all running in one process. But the idea is that you have a subscription service, you talk to it. It has, according to the spec and the implementation he provided us in open source, business logic that says how a subscription manager is supposed to handle local and remote subscriptions. Very well defined with sequence diagrams and so on. So, in other words, a local subscription manager manages all the local subscriptions, and it manages local subscribers subscribing to remote subscriptions. But what we do from the fundamental beginning is that subscriptions have a time span. So you can either subscribe in perpetuity or you subscribe temporarily. And then there's status notifications that are sent back when your subscription changes. And it also provides the acknowledgement that the subscription is completed or not. And all of that is hard-coded in the spec on how it's supposed to work. So if you try and subscribe to a cloud topic, a very good example is always the cloud subscribing to vehicle topics. And so I don't want to send to the vehicle 5 subscription requests for the same topic of vehicle speed. The cloud wants to get the vehicle speed every 4 seconds, but the vehicle speed is published every 100 milliseconds. Well, the management and the dissemination of the events based on that subscription information is handled in the infrastructure. And so even though there are 5, short story long, even though there are 5 subscribers in the cloud, it will only be sent once and then disseminated out to all the subscribers per the protocol to avoid the cost and things like that.
Clear. The question was actually easier than this.
Oh.
Because it was more about how to discover that, I mean, I'm a car, I need to talk to the cloud, so I will probably have a domain name, and at that domain name I will find the cloud, okay?
Okay.
So...
device discovery is what you're talking about then. Yeah. So when we first open sourced it, I put in the spec how we could do device and service discovery. We very quickly learned that I'm never going to do device discovery in a production vehicle. And so we said we would fix the device discovery so a vehicle, those streamer components, would know who the endpoints are. And if I need to change the endpoint, I'm going to do an update of software.
Clear.
So device discovery is very feasible to do. It's just changing the URI that you pass to the discovery service. It's just we never implemented it in production at GM, and we never got to the thought process of that is needed for automotive. Now, there's nothing stopping this idea because, again, it's not revolutionary, to be used in aviation and rail and military and other applications. So maybe in those ones, well, maybe not military you want to discover, but...
Times are changing, but yeah, different conversation there. But yeah, long story short, there's a spec for that. We need to implement it and then, let's say, probably improve it.
Yeah.
And I guess maybe this time next year we'll have a discovery hello world in one of our, probably that blueprint that we showed you.
I have a pull request that I'm going to push on the... we have a version of the discovery design and APIs and everything based on what we went to production. Now that we've learned so much from it, we're going to put out there a new version of the discovery which is much easier for developers to use. Because before it was... historically, the discovery service was a dumping ground for everything. Feature flags, vehicle calibration, you name it. And then we finally decided, no, discovery is only service discovery. So then we could create a much easier API surface for people to use, and then we just need to code it. But
yeah. But that's, by the way, anyone who is interested to take it from that level, in the repo, in the specification repo, all the APIs of these components, discovery, streamer, etc., are defined in proto-what files. So if you want to actually see how the thought process is, then you can just look at those. And maybe read the specs, but the protos will get you quite far.
Further questions, please? We've got time for one short one.
1:30 and counting.
Okay, well then, if
a short question that I don't answer.
if these two guys have gotten you all excited about this project, you have the opportunity to jump right into it in the coding lounge and the breakout area 7 today, right now. Otherwise, follow them on Slack. Get in touch with them. They have weekly meetings of different types. They're very active, I can guarantee that. So please go ahead and contact them, make your contributions there. And let's give them another round of applause. Thank you so much.
Thank you.
Thank you.
And now we're going to have a short coffee break. We'll meet again in 15 minutes. Please be sharp.
I think that went well.